Before we look at how to memorize the unit circle, let's look at how we can use the unit circle to evaluate special angles. So let's familiarize ourselves with the unit circle. The black numbers represent the angles measured in degrees. So these are our angles measured in degrees. The blue values represent our angles measured in radians. So those are our radian measures. The red values represent the sine and cosine of each of the angle measurements, whether we describe the angles in radians or in degrees. And the first number represents cosine of the given angle, and the second number represents the sine of the given angle. For example, if we want to evaluate the cosine of 30 degrees, we would first need to find 30 degrees, and then because our function is cosine, we would look at the first value, which is radical 3 over 2. So the cosine of 30 degrees is radical 3 over 2. Suppose that you were asked to find the cosine of 120 degrees. Pause the video and try this one yourself. First, we'd need to find 120 degrees. Then, because we're evaluating cosine, we'll use the first number in our ordered pair. So the cosine of 120 degrees is -1/2. We would use exactly the same process if we're asked to find the trigonometric value, in other words, the sine or the cosine of an angle that was measured in radians. So suppose that we need to evaluate the sine of this time 11 pi over 6. Pause the video and try this one yourself. First, we need to find 11 pi over 6 on the unit circle. So that's going to be right here. Then looking at the ordered pair, because the function is sine, we would need to use the second value. So remember, it's cosine and then sine. So this is the sine value. So that means that the sine of 11 pi over 6 is equal to -1/2. Now let's look at some of the patterns that will help us to memorize the unit circle. First, what do you notice about the denominators of the radian values? Basically, they repeat. So we have 6, 4, 3, 3, 4, 6, 6, 4, 3, 3, 4, 6. The numerators of those radian measures also have a pattern. Each quadrant has its own pattern. For example, in quadrant 1, we're just going to have pi. But what do you notice about quadrant 2? What can we do to each of these denominators to get these numerators? Clearly, we would have to subtract 1. So 3 minus 1 gives us 2. 4 minus 1 gives us 3. 6 minus 1 gives us 5. So the rule or pattern for the second quadrant is basically the denominator minus 1. What about quadrant 3? What do we think would happen in quadrant 3? In other words, what are we doing to 6 to get 7, 4 to get 5, 3 to get 4? So clearly here, we're adding 1. So 6 plus 1 gives us 7. 4 plus 1 gives us 5. And 3 plus 1 gives us 4. So in our third quadrant, the rule is simply just going to be add 1. to whatever the denominator is. What about quadrant 4? What are we doing to 3 to get 5, 4 to get 7, 6 to get 11? Well, this time it's not just one thing. This time we're multiplying by 2 and subtracting 1. If we did 2 times 3, that's 6, minus 1 gives us 5. If we did 2 times 4 minus 1, 2 times 4 is 8, minus 1 gives us 7. 2 times 6 is 12, and we subtract 1, that gives us 11. So the rule, or the pattern, in the fourth quadrant is whatever our denominator is, we're going to multiply it by 2 and then subtract 1. So again, if we need a visual, in the first quadrant, our numerator is just going to have pi. In our second quadrant, we're going to take whatever the denominator is and subtract 1 from it to add to whatever's in the numerator. Of course, we're going to have a pi there. So second quadrant, minus 1. Third quadrant, plus 1. The fourth quadrant will be times 2, then subtract 1. There's also a pattern with the angle measurements. What do you notice? Maybe you notice that as we go around the unit circle, we're either adding 30 degrees or 15 degrees to get the next angle, or in other words, to go from one angle to the next. Notice that if we start at the first quadrantal angle, which is 0, and if we add 30 degrees to that, we get 30. Then if we add 15 degrees to that, we get 45. And if we add 15 degrees to that, we're going to get 60. And if we add 30 degrees to that, we get 90. So basically, if we follow the pattern, 30, 15, 15, 30, and when we start in a new quadrant, we add 30 again. So 90 plus 30 is 120. Add 15 again, that's 135. Add 15 again, that's 150. Add 30 again, and it's 180. And we can follow that pattern all the way around. 180 plus 30 is 210. 210 plus 15 is 225. 225 plus 15 again is 240. Then add 30 to that, and it's 270. And again, follow the same pattern. Plus 30 in the next quadrant. 270 plus 30 will give us 300. 300 plus 15 is going to give us 315. Add 15 again, and that's 330. And then finally, add another 30, and that gives us a full rotation of 360 degrees. It's important to note that aside from doing it this way, there's another way we could think about it. Each time we start at a quadrantal angle, we're basically adding either 30, 45, or 60 to get the angles within that quadrant. So 0 plus 30 is 30. 0 plus 45 is 45. 0 plus 60 is 60. But if we start in the next quadrant, this quadrant here, we're starting with 90. So we use the same numbers. Remember, 30, 45, or 60. So 90 plus 30, what is that? That's going to be 120. 90 plus 45, that's going to be 135. 90 plus 60, that's going to be 150. And we can keep going. Even with 180, same thing. Add either 30, 45, or 60, and that gives you the special angles within that quadrant. So just to illustrate, if we add 30, what do we get? 210. If we add 45, what do we get? We get 225. We add 60, what do we get? We end up with 240. So this is one way we can memorize or relate the angle measurements to each other within the unit circle. If we want to get the value of the sine or cosine at each of these special angles, we need to notice that these values repeat around the unit circle. The only thing that changes is the sign of these angles. So for example, let's say we looked at pi over 6 or 30 degrees. So at pi over 6, and I know I have it obscured by this hand, but this is pi over 6 right here, and we compare it to 5 pi over 6, it's the same values, but we just changed the sign. In other words, positive or negative on the actual ordered pair. Even if we went to a different radian measure, so for example, 7 pi over 6. So at 7 pi over 6, we have the same numbers, but we're just changing the signs of those numbers. And also 11 pi over 6, same thing, same values, but we're just changing the signs. So these values, all the values repeat around the unit circle. We just need to remember that in the first quadrant, everything is positive. In the second quadrant, the x value is going to be negative and the sign is positive. Excuse me, the y value is going to be positive. In the third quadrant, it's going to be negative, negative. And in the fourth quadrant, it's positive, negative. So how can we remember how to change the signs here? Well, think about just how we would normally graph a point. If we graph the point here, what would we do? We would go from the origin, we would go to the right and then up. In other words, we go a positive value and then another positive value. If we went to this point in the second quadrant, we'd have to go from the origin to the left and then up. In other words, to the left would be negative and then going up would be positive. If we had a point in this quadrant, we would again start at the origin, go left, which is negative, go down, which is negative, so we'd have negative, negative. And then in the fourth quadrant, if we had this point, we'd have to go to the right, which is positive, and down, which is negative, so it would be negative, positive, negative. Also, because the values of the sine and cosine repeat, we really just need to memorize the values in the first quadrant and change the sign when we write our answer. For example, if we need to find the cosine of 2 pi over 3, what would we do? Well, first, think about what quadrant 2 pi over 3 is in. So 2 pi over 3 is in the second quadrant. Then think about the fact that cosine has to be negative in that quadrant. Remember that all the points in this quadrant will be negative, positive. And remember also that cosine is the first value and sine is the second value. Then we can remember that the denominator is 3. So it's going to be related to the other denominator of 3 that we have in the first quadrant. So we would take our cosine value, which in this case is positive 1/2, and because we're in the second quadrant where cosine is negative, then that means that our answer will be a negative 1/2. And clearly from the unit circle, we can see that it is a negative 1/2. So let's talk about how we can memorize the unit circle values using our hand. Really, we could use either hand, but it just makes more sense with the right hand. Because if we place our right hand on the first quadrant of the unit circle, each finger is going to align with one of the angles. Let's first think about what each finger would be in degrees. So notice the first finger is where 0 degrees is. The second finger is at 30 degrees. The third is at 45. Then the next is at 60. And our thumb here is at 90 degrees. So again, the first finger would be 0. The next finger is 30. The next finger is 45. Then 60. Then 90. So again, 0, 30, 45, 60, 90. 0, 30, 45, 60, 90. At this point, maybe you can pause the video and try to see if you can remember what each finger represents. So again, the fingers are 0, 30, 45, 60, and 90. We can also remember the radian values associated with each finger. First, 0 degrees is 0 radians. 30 degrees is pi over 6 radians. 45 degrees is pi over 4 radians. And 60 degrees is pi over 3 radians. And even though I don't have it written on this unit circle, 90 degrees is pi over 2 radians. So we can remember the radians by just saying 0, denominator 6, denominator 4, denominator 3, denominator of 2. So again, 0, 6, 4, 3, 2. So 0, 6, 4, 3, 2, 0, 6, 4, 3, 2. And let's see how else our right hand can help us to remember our sine and cosine values. Let's first focus on our pi over 3 or 60-degree finger. Suppose that we folded that finger down. Notice that to the left of that finger, we have one finger. And to the right of that finger, we have 3 fingers. If we look at the ordered pair for pi over 3, what do we notice? So here's the ordered pair right here. Specifically, let's look at the numerator. So we have 1 here and square root of 3 here. So basically, we can just take what we have, the 1 and the 3, put a square root over it, put it under 2, or put 2 underneath it, and then we'll know what our ordered pair is at pi over 3. Similarly, if we folded our pi over 4 finger down, we have 2 on this side and 2 on the other side. So all we have to do is to remember for both of those values, put a square root over it and put a 2 underneath it. And you'll notice that that is exactly what we have on the unit circle at that location. Notice that this also works at pi over 6. We have 3 on one side and 1 on the other. We just need to remember to put a square root over it and a 2 underneath it. But when we look at this, something should strike us as odd because we wrote square root of 1. But remember that square root of 1 is something that we can actually work out. Square root of 1 is actually 1. So let's just replace that with 1 and rewrite everything else. So our ordered pair, according to how our hands are, would be radical 3 over 2 and 1 over 2 at pi over 6. This method even works at the quadrantal angles. So 0 was one of our quadrantal angles. So our quadrantal angles are 0, 90, 180, 270, and also 360. But if we notice what happens at 0, let's say we fold down that finger. At 0, we would have 4 on one side and no fingers on the other side, so 0. So again, we took that 4 and the 0, put it above 2, and remember also to put a square root over each one. Well, what's square root of 4? Square root of 4 is 2. 2 divided by 2 is 1, and 0 divided by 2 is 0. So we have 1, 0, just as we have at the ordered pair for 0 degrees or 0 radians. At 90 degrees, or pi over 2 radians, we would have 0 on one side and 4 on the other. So again, just like we did last time, put a square root over each one, put a 2 underneath each one, and just think about what this is equal to. Well, square root of 4 is 2, and square root of 0 is 0. So what's 2 divided by 0? That's going to be 0. And what's 2 divided by 2? That's going to be 1. So we have exactly the same ordered pair at 90 degrees, or pi over 2 radians, as we would already have had if we had just used the unit circle. So let's see if we can apply what we just learned. Suppose that we need to find the cosine of 5 pi over 4. First, think about what quadrant this would be in. In this case, remember the relationship for the radian values in each quadrant. In quadrant 1, everything is just going to be pi over. In quadrant 2, it's the denominator minus 1. In the third quadrant, it's the denominator plus 1. And in the fourth quadrant, it's the denominator times 2 minus 1. So because we add 1 to get our numerator here, we know that this angle, 5 pi over 4, has to be in quadrant 3. So then we're going to remember that in that quadrant, actually let's remember all the quadrants. The first quadrant, the points are positive, positive. In the second quadrant, they're negative, positive. In the third quadrant, it's negative, negative. And in the fourth quadrant, it's positive, negative. So since this angle is in the third quadrant, and remember that it's cosine and then sine for the ordered pair, the cosine is going to be negative, but the sine is also going to be negative. We also remember that all the values repeat. So if we have the values for 5 pi over 4, they're going to be the same values that we have for just pi over 4. So at this point, we can use our hand to remember how to find the cosine at pi over 4. And we're going to have to put that particular finger down. So again, for the cosine of 5 pi over 4, remember that the denominator is 4. And if we remember how the fingers go, this one was 0, this one had a denominator of 6, this one had a denominator of 4, this one had a denominator of 3, this one had a denominator of 2. So if we wanted to evaluate cosine of 5 pi over 4, this is the finger that we would need to put down. So once we put that particular finger down, what we can do is we can look at what we have on either side. On the left side, we have 2. And on the right side, we also have 2. So we need to remember to put a square root over it and put a 2 underneath it. So that's the ordered pair that we would have at pi over 4. But because our angle is in quadrant 4, remember that we said in quadrant 4 it was going to be negative, negative. Both of these values would have to be negative. So our cosine of 5 pi over 4 has to equal this first value, which is negative radical 2 over 2. Now pause the video and try this one yourself. Suppose that you had the sine of 5 pi over 3. What quadrant would this angle be in? Well, 5 pi over 3, let's think about what we'd have to do. So what's the pattern that we're applying to this denominator to get 5? Well, first, 2 times 3 is 6, and if we subtract 1, we get 5. This rule of multiplying by 2 and then subtracting 1 is what we do in quadrant 4. So the angle 5 pi over 3 has to be in quadrant 4. Remember that in this quadrant, all the points are positive, negative. So that means that our cosine is going to be positive and our sine is going to be negative. Next, because the denominator is 3, we need to relate this in the first quadrant to pi over 3. So we're going to need to fold that particular finger down. So the sine of 5 pi over 3, or pi over 3, is going to cause us to have these values here. Notice that on the left we have 1, and on the right we have 3. We just need to remember to put a square root over each one and a 2 underneath each one. Square root of 1 is 1, and square root of 3 we can't do, so we're just going to leave it like that. Remember that the first value is cosine and the second value is sine. But remember that this angle that we have, 5 pi over 3, that this angle is in quadrant 4. So in quadrant 4, we know that all the points in quadrant 4 are going to have a positive and then a negative value. So in other words, the cosine is going to be positive, but the sine has to be negative. And we were asked to find the sine of 5 pi over 3. So in other words, the sine of 5 pi over 3 is going to equal negative radical 3 over 2. Just a quick note, for some of us, the hand way of memorizing or evaluating unit circle values might not work too well. We might forget exactly how it works or why it works. But what we could do is we could just notice some other patterns that might help us to remember what these values are. For example, if we start on the right side of our unit circle, we'll notice that we have in the numerators 1, 2, 3, and on the other side we have 3, 2, 1. When we get to the left side, same thing. We have 1, 2, 3, and also 3, 2, 1. And these values are going to repeat as we go around the unit circle as well, because we have on the other side it flips when we get down to the bottom. It'll be 3, 2, 1, and then 1, 2, 3. And then in the last quadrant, the same pattern. We have a reflection. So we're going to start with 1, then we'll go to 2, then 3. And then if we start with 1, 2, 3, the other one's going to be 3, 2, 1. So we have multiple ways that we can memorize these unit circle values. And if you really need to, go back to our special right triangles and see if you can come up with the actual unit circle values if you really have to.